Hello guys, we are starting 9.7 notes today on special right triangles, and we're going to talk about two different kinds of special right triangles, and we know they're special according to their interior angles. So obviously in a right triangle, one of our angles is going to be 90 degrees, and when the other two angles are either 45 and 45 or 30 and 60, we have a special relationship with the ratios of their size that makes it easier to find missing sides without using Pythagorean theorem. So the first one we're going to talk about is the 45, 45, 90 right triangle, which is also isosceles, because if you'll recall, when our two base angles are congruent, our two sides are also congruent to each other. So in a 45, 45, 90 right triangle, our sides are related in the ratio of x for our two sides and x times the square root of 2 for our hypotenuse. So whatever x is for a triangle that is 45, 45, 90, the two sides are going to be that length, and the hypotenuse is going to be x on the square root of 2. So let's see that in action with some practice problems. Down here on A, I know if this side angle is 45 and I have a right triangle, my other angle is going to be 45. So for 45, 45, that means my two legs are congruent. So if this side is 9, that means that this side y here is also 9, because that is my congruent leg. And then our hypotenuse is going to be whatever x was beforehand times the square root of 2. In this case, x is 9, so our hypotenuse is going to be 9 on the square root of 2. Now moving on to B, again, I've got a 45, 45, 90, so these two sides are congruent, which means that y is also 3 on the square root of 2, and our hypotenuse is going to be the side length times the square root of 2. So that's going to be 3 square root of 2 times square root of 2. And remember, when we multiply radicals, what's outside gets multiplied together and what's inside gets multiplied together. So we have an imaginary 1 on the outside, so that's going to give us with 3 on the square root of 4. And remember, the square root of 4 is 2, and I'm running out of room here, so I'm just going to go down just a little bit. I'm going to end up with 3 times 2, which is 6. So our hypotenuse here is 6. Right, C, another 45, 45, 90. So x and y are going to be the same. Now if my hypotenuse is 8 on the square root of 2, that means that my two sides are both going to be 8. Because I solved this by dividing by the square root of 2. And 8 on the square root of 2 divided by the square root of 2. My square roots cancel, and I'm just left with 8. All right, D, again, A and B are going to be the same. So whatever A is times the square root of 2 is going to be equal to 10. So I'm solving for A. I'm going to divide by the square root of 2 on both sides. And remember, I can't have a radical in the denominator, so I'm going to rationalize that one. And I'm going to get 10 on the square root of 2 over the square root of 4. Remember, the square root of 4 is 2. So I'm going to have 10 square root of 2 over 2. And I can simplify this because 10 and 2 have a common factor of 2. So I get 5 on the square root of 2. And that is the same for A and for B, because they are congruent sides. Moving on to E and F, these are both going to be multi-part problems. So I'm wanting to get to X, so I first need to figure out this triangle here. So if my sides in this triangle are both 6, that means the hypotenuse for our triangle at the bottom is 6 on the square root of 2. Now what's the hypotenuse of the bottom triangle is a side of our top triangle. So these two sides are going to be this congruent to each other. So I find my hypotenuse by multiplying by the square root of 2. And so I'm going to get 6 on the square root of 4. And square root of 4 is 2. So x is 12. And last but not least, for our 45, 45, 90, I want to get to x, so I'm going to start with this one first, and I'm given the hypotenuse. So to find the side, I need to divide by the square root of 2. And so I'm going to need to rationalize my denominator, or what's outside gets multiplied together and what's inside gets multiplied together. The square root of 4 is 2. So I get 5 on the square root of 12, but the square root of 12 can be simplified because the square root of 12 is equivalent to the square root of 4 times 3, and 4 is a perfect square. So I can bring out a 2, and my square root of 3 is still there. So 10 square root of 3 is the length of the side for this triangle here. So 10 on the square root of 3, which is the hypotenuse for the triangle with our x that we're trying to find. So again, to find the side, I have to divide by the square root of 2. So I'm going to take 10 square root of 3 divided by the square root of 2. And I need to rationalize my denominator. So I get 10 square root of 6 over the square root of 4. The square root of 4 is 2. And so I can simplify my 10 and my 2, and I get 5 on the square root of 6 is equivalent to x. And that is our notes for the 45, 45, 90 right triangle. So as I mentioned before, we have a second type of special right triangle, and that is when its interior angles are 30, 60, 90. When they're in that relationship, our ratio between the two sides is the side opposite the 30-degree angle, and this is going to be very important. You have to pay attention to the side opposite the angles. So the side opposite the 30-degree angle is x. The side opposite the 60-degree angle is x times the square root of 3. And the hypotenuse, or the side opposite our right angle, is 2 times x. Okay? And so again, x can be any number depending on our triangle we're working with. So let's look at some examples. On part A, we have our 60, 30, 90 right triangle. And what we're given is the side opposite the 30-degree angle. So that means in our relationship ratio, x is equal to 8. So our side opposite the 60-degree angle would be 8 times the square root of 3. And our hypotenuse x would be 2 times 8, which is 16. Right. Example B. I find it keeps it straight if I fill in that missing angle so I know what I'm given. Here we're given our hypotenuse, which is twice the side opposite my 30-degree angle. And the side opposite our 30-degree angle here is y. So y is going to be 14 divided by 2, which is 7. And x is our side opposite the 60-degree angle, and so that is going to be this side times the square root of 3. So 7 times the square root of 3. Part C. This time we're given our side opposite the 60-degree angle, so I'm going to look at that number in front of my square root, 4 square root 3. That tells me that my side opposite the 30-degree angle, which is y here, is going to be 4. And x, my hypotenuse, is going to be twice the side that's opposite my 30-degree angle, and 4 times 2 is 8. And for D, this time we're given our side opposite the 60-degree angle, and that is 5 on the square root of 6. So I need to find this number n right here. So n times the square root of 3, remember, is equal to our side opposite the 60-degree angle. So that's going to be 5 on the square root of 6. So to solve for n, I'm going to divide by square root of 3. And again, I'm going to have to rationalize because we don't like radicals in our denominator. So we're going to get that n is equal to 5 times the square root of 18 over the square root of 9. So we get 5 square root of 18 over 3. And the square root of 18 can be reduced and simplified. 9 is a perfect square, and that's a factor of 18. So I'm going to get 5 times 3 on the square root of 2 over 3, which is 15 square root of 2 over 3. And the 15 and the 3 simplify. So I'm going to get 5 square root of 2 is n on part D. So 5 on the square root of 2. And then m is twice my side that's opposite the 30-degree angle. So m is just going to be 2 times 5 on the square root of 2. And so we're just going to multiply the 2 and the 5 together, and we get 10 square root of 2. And then again, we have 2 multi-step examples here. So looking at E, we're going to have to make our way down. And I'm going to go ahead and label in my angles I've not given so I can keep it straight. On this first upper triangle, we're given the side that's opposite the 30-degree angle. And what I need in order to make my way down is to find this side that's opposite my 60-degree angle. So this length right here is going to be equal to this side times the square root of 3. So 6 times the square root of 3 is the length of that side. And this is the hypotenuse of my lower triangle, and x here that we're looking for is opposite the 30-degree angle. So recall our hypotenuse is twice the length of the side opposite the 30-degree angle. So whatever 2 times x is going to be 6 on the square root of 3. So I'm just going to divide by 2. And 6 divided by 2 is 3, so x is 3 times the square root of 3. All right, last one, another multi-step. I'm going to fill in those missing angles. For F, we're given the side opposite the 60-degree angle on our lower triangle. And to make my way up, I want to find my hypotenuse. But in order to find my hypotenuse, I need to know what the side opposite the 30-degree angle is. So this one's going to take a couple more calculations. So first, I need to figure out, let's call this side y. Y times the square root of 3 is equivalent to 6 on the square root of 2, because whatever y is times the square root of 3 gave me this side. So I'm going to solve that by dividing. And again, we're going to have to rationalize. So I get 6 on the square root of 6 over the square root of 9. Of course, the square root of 9 we know is 3. And this simplifies. 6 divided by 3 is 2. So this side y right here is going to be 2 on the square root of 6. So now I can find my hypotenuse, and that's going to be twice this. So this side is 4 on the square root of 6. And this is the side opposite the 30-degree angle on my upper triangle. And what I'm looking for, x here, is the hypotenuse. So that's going to be twice this. So x is twice 4 on the square root of 6. 4 times 2 is 8. So x is equal to 8 on the square root of 6. And that wraps up our notes on 9.7.